Okay, so on number 4, we are going to be using the law of sines to solve some application problems. So on example 7, it says an observer on the ground sights a plane at an angle of elevation of 41.2 degrees. So that guy can be represented by this little purple dot. Okay, there's his angle of elevation of 41.2 degrees. He sees the plane. And then it says at the same time, a second observer 3,000 meters farther away along the same line of sight measures the angle of elevation as 35 degrees. So the second observer is standing over here, 3,000 meters away, and he sights that plane at an angle of elevation of 35 degrees. From that information, we are going to be able to figure out how high is the plane. We're actually going to be able to figure out what is the plane's altitude. Okay? We'll just call it H. Now, in this right triangle that we just formed, let me scroll a little bit here. In the right triangle that we just formed, let me kind of try to copy it right down below here. Okay, in the right triangle, really all we know is that this angle inside here is 41.2 degrees. Okay, we are trying to find the height. Okay, well, we don't have enough information. Even though this is a right triangle, we don't have enough information using our trig functions quite yet to find what that height would be. We need another either leg or we need the hypotenuse. Okay? So I think if we are able to get the hypotenuse number here, we'd have enough information to solve for the height. Now, that hypotenuse number there is the same thing as this measure there. And in our little triangle that's formed over here, let me call this hypotenuse C, okay? So what you know is, and I'm going to try to draw this other little skinny triangle. I'm going to over-exaggerate it just a little bit so that we can maybe, hopefully, label some stuff, okay? This angle in here is 35 degrees, and I'm just gonna kind of draw an arrow to it like they did. That angle is 35 degrees, and we're trying to find the side opposite of that. Well, we need a pair of something. Okay, we know that this is 3,000 meters here. All right, that would be helpful if we had this angle opposite it above, that little bitty angle up there. Well, what we do know is along a straight ground here, this exterior angle was 41.2 degrees, and so we know that this angle along with this angle here are going to be supplementary angles. Okay, they add up to be 180 degrees. So that angle, let's call it, I don't know, angle A. Okay, that's the orange angle A. It's going to be supplementary to 41.2 degrees, which that is, I can't do that in my head. It's so sad. It's so dumb. 138.8. Okay, so this one is 138.8. This one is 35. So what does that leave us for the angle up top here that we need? I'll label that kind of in blue. Okay. Maybe we'll call that angle B in this triangle. Okay. So angle B is going to be 180 less the measures of the other two angles, the 138.8 and the 35. Okay, so that angle, angle B, is going to be 6.2 degrees. Little bitty. 6.2 degrees. 6.2 degrees. Now, I know that doesn't seem great, but what we have is enough information to use the law of sines to solve for side C, which is what we ultimately need over in this other triangle, in the right triangle. So here we go. I'm going to say the sine of 6.2 degrees is to its side opposite. 6.2 side opposite is the 3,000 meters, as the sine of 35 degrees is to its side opposite, and we've labeled that to be side C. And that is the same side C that we need over there in our right triangle here in a minute. Okay, so solving for C by cross multiplying and dividing, okay, I'm going to take 3,000 times the sine of 35 degrees divided by the sine of 6.2 degrees, and C is going to be equal to, large number, 15,923.77 meters. Okay, now that's not my answer yet, okay? That is this orange segment C. Actually, I have it labeled in orange over there. So what I found here is that this hypotenuse of my right triangle is the 15,923.77 meters. Okay? And now I've got enough information to solve for H, to find what the height of that airplane is. Look at this right triangle. Okay? From this angle down here in your right triangle, you're trying to find the opposite side. You have the hypotenuse. What trig function deals with opposites and hypotenuse? It would be the sine, right? The sine of 41.2 degrees is equal to the opposite, that's the H, that's the height, over the hypotenuse, that's the 15,923.77 meters. Okay? Now, when we multiply both sides by the 15,923.77, okay, we're going to get that the height of this, I'm doing this calculation right down here, I'm going to have 15,923.77. And here I'm carrying out a lot of decimal places because I really want my answer to be as accurate as possible. I need to multiply that by the sine of 41.2 degrees. And that's going to give me H, 10,488.8. Now, this said round to the nearest 100 meters. The nearest 100 meters would be to round to 10,500 meters. Okay? So our answer, rounded to the nearest 100 meters, okay, would mean we have a height of 10,500 meters. You can put a comma in there if you want to, comma. Okay, so that's how that problem would work. We had to use a combination of the law of sines to find a side that we needed here, and actually it was the hypotenuse of that right triangle. Okay.